This is Monitoring Openstack, the relationship between Nagios and Ceilometer. And at this time, could you please put your hands together for Konstantin Benz.
Okay. Thank you very much. The topic of today is monitoring Openstack, which is a cloud computing platform. I'll first tell you some words about me. I'm Konstantin Benz. I'm working as researcher at the Zurich University of Applied Sciences. And I'm working in the area of cloud computing in a European Union project, which is called Sci-Fi. This is an Openstack cloud federation consisting in 17 nodes or 17 cities, which have their own Openstack instance installed. And this cloud federation serves as a test environment for future internet applications, like applications in areas of smart cities, public health, traffic management, and it provides the whole IT infrastructure for that. What's important to us is that this cloud federation is using Nagios as the main monitoring tool of that project. And this is the reason why I want to talk to you about this in the presentation. I want to show you how you can use Nagios to monitor an Openstack cloud environment. And I want also to show you how to integrate Nagios with Openstack as the main monitoring tool. I will show you the monitoring requirements we have in a cloud environment, which is different from the normal client-server delivery model you have. And I show you the cloud management software, Openstack internals a little bit, and the Ceilometer component, and compare it to the Nagios monitoring tool. And then I will show you two different ways on how to use Nagios to monitor Openstack cloud software. What is a cloud? What's different in a cloud between a cloud and a normal virtualization environment? Well, the cloud provides an elastic way, provides resources in an elastic way. Elasticity is very important in the cloud, and this is also important when you consider Nagios monitoring. If Nagios has to elastically configure itself to monitor all the cloud resources. Why does someone use clouds? Well, a cloud consumer doesn't have to pay fixed costs. The cloud customer pays only for the resource utilization, and the cloud provider has also a benefit. The cloud provider can get money back for overcapacity of server resources. That's the main reason why someone uses clouds. And now to the Openstack architecture. Openstack is an open source cloud computing software which consists in multiple services which have their function inside the cloud environment. They all provide a virtual machine. That's the main reason we provide virtual machines inside this cloud environment. And the most important components of Openstack are the Keystone authentication service, the glance image service that provides an image. You can think of an image like a template for the virtual machine you want to provide. And the main component of Openstack is this Nova service. This is the component which is responsible for the management and the provisioning of these VM instances. The Openstack architecture also provides its own monitoring component. This is the Ceilometer component, which is monitoring utilization of the VMs. Monitoring of the VM utilization is important for the cloud consumer and the provider, because in a cloud you pay for resource utilization, so that data is very important in the end for paying your cloud computing usage. There are two things you have to monitor in Openstack. One is the operation of Openstack itself. Openstack has some services, Glance, Nova, Swift, and this should be up and running, otherwise you cannot monitor anything and you cannot operate your cloud. And the other thing you have to monitor is the virtual resources, the VMs that are provided to customers. You have to monitor CPU usage, memory usage, and so on, and especially if the resource is available, the VM should be up and running, and the utilization. In Openstack, this is normally done by the Ceilometer component, and Ceilometer is a collector that gathers the utilization data directly through the Openstack API. And in Nagios speak, you would call this a passive check. It's if you create a new VM, this is normally published in the compute component, in the Nova compute component, and Ceilometer registers that and gathers the data that this resource is up and running. Why is this Ceilometer component not enough to monitor your Openstack environment? Why do we use Nagios in addition to this Ceilometer component? Well, Ceilometer monitors the virtual resources through the APIs, but not the operation of these APIs. So if these components fail, Ceilometer won't collect any data. So that's why we have to use Nagios in addition to Ceilometer in order to correctly monitor the Openstack environment. Let's compare a little bit the different monitoring tools. The Nagios tool, you all know about it. It's, you have a Nagios core server somewhere, and you have some clients or some systems which are monitored by Nagios with Nagios plugins, and they are checked, and they generate some messages like about the status of services that are running on the system. They could be okay, warning, critical, or unknown, and these results get delivered to the Nagios dashboard. It's quite effective monitoring solution, especially for monitoring physical servers. It allows for fast reaction, and the strength of Nagios is its extensibility and customizability. In order to monitor virtual resources, Nagios must be extended too, because if you start a new VM or terminate it, Nagios must change its configuration. It must know that this host is existing there, or it must know that this host doesn't exist anymore. Now in the Ceilometer tool, you're just pulling the Openstack component through their APIs, collect all the data, and gather it in a Ceilometer database. And it's basically a metrics collector or a usage collector. It's fully integrated in Openstack, and it collects the most important metrics and stores also their change history. The weakness is Ceilometer does not monitor the physical hosts where the Openstack components are running. This is one weakness about this, and this is why we have to use Nagios. Now, how can Nagios be integrated in the Openstack environment? Well, there are two alternatives. One alternative is to use Nagios basically for monitoring the Openstack services and use that connection to the Ceilometer database to collect the virtual machine data. We can use Ceilometer as it is. It collects the virtual machine data. It gathers everything in the database, and then Nagios just queries that database and gets the data back. It's simple, easy to implement, no extra Nagios plugins required, and the Ceilometer tool can be left unchanged. Well, one drawback of this approach is that the data is somehow duplicated. It stores one time in the Ceilometer tool and then on the other hand in the Nagios server. This is not always optimal. Depends on what you want as a solution. Well, how is this Ceilometer plugin implemented? It's a Nagios plugin on the client that hosts the Ceilometer API. You can install a normal shell script. What's required for that shell script? You have to get access to Openstack, so you can query Ceilometer, and the Openstack API, you have to provide a username, tenant name, password, and the authentication URL. And the plugin should receive some parameters to get that data it collects into Nagios. And basically what you need is the resource to be monitored, the host in Nagios speak, a service, the metric collected in Ceilometer, like CPU utilization, for example, warning threshold and a critical threshold, and you should put that in your Ceilometer plugin script. Well, in order to get the VM which should be monitored, we query the Nova API, and then we query the Ceilometer API to get the metric, and then we check the metric and we gather the return code according to the thresholds you set. Return code 1 means there's a warning. Return code 2, there's a critical warning. You should alert something. And you just feed that data into Nagios, and Nagios will register that. Yeah, and output that return code. The plugin can be downloaded also from GitHub. I have published it on GitHub. Additionally, I recommend to use NRP or for remote execution of Nagios calls to Ceilometer, and install the NRP on Nagios core server and the server that hosts the Ceilometer API. And on that server, you just have to change the config of NRP, and everything will work as you expected. Well, there's how it can be implemented physically. You have an OpenStack instance with a management node responsible for monitoring other OpenStack nodes. You have a controller node which is responsible for the configuration of these cloud resources, and you have a compute node which is provisioning these virtual machines. And on this compute node, you have the Ceilometer agents, which are collecting through the Nova API or the Neutron API all the data of these virtual machines and feed it into that Ceilometer database. And on the same time, you can install a Nagios server here just to gather data from that database. This is one possible implementation of this first alternative to monitor Nagios, to monitor OpenStack with Nagios. Another alternative is to avoid using Ceilometer tool. In Ceilometer, basically, you gather all the data from the VMs and you feed Nagios with that data. But there's a simpler way. You can just use Nagios to monitor not only the physical hosts, but also the virtual machines. But if you do this, you have to consider that this requires an elastic reconfiguration of Nagios. Normally, the OpenStack user creates new machines, maybe 100 new virtual machines, or terminates new machines. And so Nagios must know that the machines doesn't exist anymore and must reconfigure it elastically, and this requires a rather complex Nagios configuration. Well, what's the problem behind that? Well, the resources are provisioned dynamically. The Openstack controller nodes provides a virtual machine image or a template for this virtual machine, and as soon as an OpenStack user wants to create a new virtual machine, it uses that image and creates that virtual machine, and the Nagios server should then know about this new existing machine and monitor the utilization on that machine. Well, what happens if the virtual machine is terminated by the end user? Well, Nagios normally, without configuration change, Nagios assumes that this is a host failure. It doesn't see that the virtual machine is terminated, cannot reach it, so it creates an error message or a critical message. And this is not the behavior you want as the person who is responsible for monitoring OpenStack. Well, there's a solution. You can change some things in the Nova API, add a trigger which reconfigures Nagios as soon as a new VM is created. The Nagios configuration must be updated accordingly. And then Nagios will know about that this is not an outage, this is a VM which is terminated by the user. Another problem is, in order to monitor a virtual machine, this virtual machine must have some Nagios plugins installed, or otherwise Nagios cannot monitor it, because there are some maybe some NRP plugins or NSCA. It depends on what you want, but normally it's you have to configure some things on that virtual machine. In the OpenStack environment, there are two possible solutions. You can use a VM image that only contains the Nagios plugins, so the user can only create virtual machines that already contain the correct configuration and the plugins. Or another solution could be to use a package management tool like Puppet, Chef, Ansible, or something else. This is not such a big deal. If you have the correct VM image or a configuration management tool, this should work as expected. Well, let's see how one possible implementation for this. We can create a trigger for the dynamic Nagios reconfiguration, and this can be done with a simple shell script, which is querying the Nova API to get a VM name and an IP address as soon as a new VM is created. It creates a configuration file. yeah, and enters VM name, IP address. You need this in Nagios to know that this host exists, creates a config file, sets some permissions, and move it to your Nagios directory where your config files are located. And then you change the Nagios config file at this line, yes, and restart Nagios, and then it should work fine. This is possibly the simplest solution. It has one drawback: you have to restart Nagios, and this is not always what you want if you have thousands of servers or something going on. Restarting Nagios is not a good option. Yeah, the configuration change is really bad if you have to restart Nagios. So I'd recommend to use something to reconfigure Nagios elastically without restarting everything over and over again. So there are other possibilities to implement that. For example, you can add a trigger for the Nova API and use the Nagios event broker module. Or you can use auto configuration via Nagios QL. Or another recommendation could be use Nagios XI instead of just Nagios Core, because Nagios XI provides some auto configuration tools. You have to consider if you're willing to pay the cost. It's not very expensive if you consider that you have some configuration efforts. If you're using Nagios Core and these two plugins, you have some labor costs. So it may be cheaper to install Nagios XI and use the advanced features of that tool. There's a good way to dynamically reconfigure Nagios could be to use a Puppet Master. A Puppet Master can trigger VMs to install the Nagios NRP plugins, so you can automatically monitor, or you have automatically configured machines that are monitored by Nagios, and the Puppet Master can at the same time trigger your Nagios server to update its configuration. Same can be done with other configuration tools like Chef, Ansible, etc. Drawback is that these are quite heavyweight tools. Puppet scalability is not so good if thousands of servers have to be commissioned or decommissioned dynamically. But well, in some situations, if you don't have to change many virtual machines at the same time, if you're a medium company, not a very large company, then this could be the right way to go. There's another possibility. You can use just simple Python fabric script with QCin. This is a lightweight package management library in Python, and this library does the same. You can install the Nagios NRP plugins on the VMs and can force the Nagios server to update its configuration. And basically you have to write a Python script which uses the Python, the Openstack API in Python to connect to the Nova API, get a list of the servers, write a list of VMs, and then import a recipe for the VMs, one for the Nagios server, use SSH to SSH in that servers, and then assign recipes to that servers, to that VMs to configure them, and also to the Nagios server to reconfigure it dynamically. What this Fabric API is doing, it can SSH into different machines and execute some remote tasks on them. And one task could be to ensure that a package like NRP is installed on this Linux machine, or that that some configuration tasks are executed, or some shell tasks. This is all fine with the Fabric API. Well, which option should we choose? We have different options. One could be to have Ceilometer to collect all the data and just Nagios as a front end to query that Ceilometer database. Other solution could be to use Nagios only with a shell script that updates the configuration. Use Nagios with Puppet to automatically configure VMs and Nagios, or use a Python script with Fabric and this QSIN Python library. The advantage of the first one is that it's a very easy solution. It scales well. Drawback is that you have data duplication. You duplicate your database. You have two monitoring systems which are working in parallel. This adds some complexity, which is not always the best practice. The advantage of the other solutions is that you don't have data duplication. Shell scripts is quite easy solution, but it's difficult to maintain, possibly insecure. Nagios is forced to restart. So it's better to go with a configuration management tool, which is automatically updating the VMs and the Nagios configuration, and which allows for elastic reconfiguration of Nagios. The drawback could be that this is a heavyweight solution, possibly not good, it doesn't offer good scalability, especially for large clusters, and therefore we can also go with a lightweight Python solution. Possibly you have bigger configuration effort for package management with strong dependencies between packages. This is maybe a smaller drawback you have, because Puppet is quite sophisticated in managing packages that depend on other packages, and it uses some hierarchical package management, and this is maybe an advantage of the Puppet configuration tool. Now, what did we talk about? We talked about how to use Nagios to monitor your Openstack cloud environment. We saw that cloud environment has a monitoring requirement which demands for high elasticity, dynamic provisioning of virtual machines. This has an influence on your Nagios monitoring tool, because Nagios has to be reconfigured elastically. We have seen the different tools, Nagios and Ceilometer tools, as for monitoring Openstack. Nagios is very extensible, very flexible, and Ceilometer captures the data directly through the Nova API. So there's a possibility to either use Nagios as a front end for Ceilometer and let Ceilometer monitor the VMs, or the alternative that Nagios is used as standalone tool for monitoring the VMs and the services. And when implementing that alternative, we have seen that there's a need for a dynamic reloading of the Nagios configuration, and we have discussed the advantages and drawbacks of some different implementations. So, are there any questions to that talk? Yes?
There's got to be. Okay.
Oh, this one, okay.
Okay, thank you. Seeing that maybe the interesting thing about Openstack is a very dynamic platform, and the most complicated is changing automatically virtual machines that turn on and resources. Do you have any tips or any information about graphing or how to see it in dashboards or something related to that? Because maybe that's like the next step even.
Yes. The question is about dashboard for...
Like, for example, you talked about changing the configuration files automatically, and that's okay, but what about something graphical, about thinking in virtual machines moving from servers or resources changing, and maybe dashboards or Nagios or something that could change also automatically depending on how the OpenStack changes, if you have any experience with that?
Yes. You mean if you move one virtual machine from one node to another one, yes? Well, basically you have to install a trigger for that. Can do this either inside Openstack using the Openstack Python API. Openstack is fully Python-based tool, by the way. And in the Openstack dashboard, there's a dashboard tool similar to the Amazon dashboard. You can maybe modify modify the code to trigger reconfiguration of Nagios. This is possible, but you have to hack into OpenStack. This is the drawback of that. Yeah. We're not doing this at the moment because it's we don't want to change the OpenStack code base too much. Basically, because we're a federation node in an OpenStack Cloud Federation, and every node should have a little bit similar configuration. But if you have your own OpenStack cloud and you're the sole responsible person or the sole responsible organization for that node, then you can do this, providing that you have some documentation of that OpenStack code change and some proper change management practices established. Yeah.
Any more questions?
Yeah.
Yes.
Are you monitoring storage devices, and if so, how dynamic are they?
Storage volumes inside OpenStack, yes. I've shown only the way how to implement this for VMs. I can do the same thing for storage volumes, but in that case you wouldn't use the Nova API, you would use a tool called Cinder. It's the component responsible for managing volumes inside OpenStack, yes. But basically it would work the same way like it is described here. You would just have a Cinder client instead of the Nova client, and Cinder volumes list, yes. This would work pretty much the same, yes. Currently we don't have we only do this for the VMs, but for the volume management it would work the same way.
Anybody else? Alrighty, can you give a nice round of applause, please? Konstantin, Benz.
Thank you very much.
Thank you.
Thank you.